Hey, what's up? I'm Mr. Bahork, and today I want to talk about distance, speed, and time. This is intended for my 7th grade science class, not math. Well, it's all math anyway, but this is my 7th grade science class, and if you're interested in a physics video that is a little bit more advanced as far as distance, speed, and time are concerned, you're going to have to look elsewhere because this is very, very, very basic level physics, okay? Just kind of introducing the concept of distance, speed, and time and how to graph this stuff. So let's say I am cruising around and I am driving, and let's say after a minute, I'm driving, let's say, really, really slow. So after 1 minute, I have gone 1 meter. In fact, why would I even be driving if I'm moving that slow? Let's say I'm walking. I'm walking super slow. In fact, I'm strutting my stuff. That's what they used to say. So I'm strutting my stuff. I'm walking around. After a minute, I've gone 1 meter. It's almost like I'm moving in slow motion. I'm so cool. Then after 2 minutes, I have gone 2 meters. After 3 minutes, I have gone 3 meters. So I think you're seeing the point here. So if I were to graph this, let's say on the x-axis, this will be my time axis. That's time. And on my y-axis, this will be my distance axis. That's distance, and that's going to be measured in meters. And the time is going to be measured in minutes. Sweet. All right, so after 1 minute, I've gone 1 meter. After 2 minutes, I've gone 2 meters. And after 3 minutes, I've gone 3. And I think if you see the pattern, it keeps going 4 minutes, 4 meters, 5 minutes, 5 meters. Okay, assuming that I don't speed up or slow down or stop. So keeps going, and then you'll notice something. This makes a straight line. I'll draw it in green. Purple and green to celebrate the Hulk. This makes a straight line. Well, that line, okay, it's got a bunch of different properties associated with it. Okay, that line, it has a very special property called the slope. And the slope is basically how steep it is. Okay, it's more so a comparison of how much it goes up to how much it goes side to side. Well, if we look at this, let's talk about how much it rises. Let's say, okay, let's use the 3 minute one. So it rises 3 meters, but in order to get to the point on the line, you have to run 3 minutes. So it's a comparison of 3 meters for every, and when we say for every or per, okay, 3 minutes, or 3 meters, excuse me, 3 meters, for every 3 minutes. Well, that's a simple division problem. What's 3 divided by 3? That's 1. Okay, so I have gone 1 meter, and the units don't magically go away. I've gone 1 meter for every 1 minute. And what is that? Well, that's the speed. Okay, that's how fast I'm going. I'm moving at 1 meter per minute. That is my speed. So the slope of this line represents how fast I'm going. Okay, well then let's do a little bit of a different example. So let's erase some of this. Let's kind of play around with the numbers. Erase this. I'll even erase the graph, and we'll get a fresh one. Okay, and let's say instead of moving so slowly, I'm going to start to speed things up a little bit. I'm walking around the places, maybe the mall or something. I'm strutting my stuff. Okay, I'm happy that I know about science and math and stuff like that, so I'm rocking it. And I pick up my pace because now I'm in a hurry. So after 1 minute, I've gone 3 meters. Ooh, moving fast now. That's a little sarcasm right there. Okay, so after 2 minutes, I've gone 6 meters. After 3 minutes, oh man, I got 9 meters. So let's plot these points. So at 1 minute, time is still going to be on the x-axis. So time's still here. That's measured in minutes. Maybe I should write in a color that you can actually see. How about orange? All right, distance, and that's going to be measured in meters. And we're going to find that on the y-axis. Center that up again. There we go. All right, so let's plot these 3 points. We got, let's use green to plot them. Okay, at 1 minute, I've gone 3 meters. At 2 minutes, I've gone 6 meters. And at 3 minutes, I've gone 9 meters. Well, hey, look, that lines up again. And so let's draw a line through that. Just want to see what it looks like. Awesome. Okay, so we draw our line through that. And you'll notice that, again, we can find the slope. It's how much it rises by how much it runs. So if I'm going to start here, I'm going to go and rise up. Let's say I'm going to rise up to 6. Why not? I'm going to run over 2. I rise 6. I ran 2. Those numbers should be familiar. It's because if I go up 6 on the y-axis, that means I went 6 meters. And I run 2 on the x-axis. Well, since time is the x-axis, it means I went 2 minutes. And again, this is a simple division problem. 6 divided by 2, well, that's 3. So that means I was moving 3 meters per minute. And that's my speed again. So you'll notice that the slope of these lines is the speed. And compared to the last line that I drew, okay, the line from the previous problem, it went a little bit like this. It's good enough. Okay. It went like that from when I was moving a lot slower. Well, notice the difference. Look how steep this line is, this purple line. Okay, it's not as steep as the blue line that I drew. That means the blue line that I drew, where I was moving 3 meters per minute, look how it's steeper than this line, where I was moving 1 meter per minute. Well, because it's steeper, it shows that I was moving faster. That's my speed. So that's why slope is important. So this slope, this comparison between the change in y, or I like to say the rise, compared to the run of the graph. And we say rise, I think the y-axis, I think the x-axis for run. When you compare those two numbers, well, it represents the speed. The slope is the speed. So maybe I could rewrite this and say, well, instead of slope, it's the speed. And the rise, well, on the y-axis, what was that? Well, that was distance. Speed is equal to distance. And what was the run? Well, that's time. And that's where this formula comes from. Speed equals distance over time. Okay. Well, I'm Mr. Bajork, and that's pretty much the sum of what I wanted to do with distance, speed, and time today. Yes, and remember, this was for a 7th grade science class. So if you are looking for acceleration or finding a tangent line or doing a little bit of calculus, relating all these velocities and stuff like that, you're going to have to find a different video. So anyways, I'm Mr. Bajork, and that was distance, speed, and time.